Welcome back to the Learning Studio. This is our mathematics series, where we break down the most important concepts that power the past, present, and future of science and technology. If you haven't already, you can follow us by clicking the link below, and you'll also find the entire playlist in the description, so you can watch every episode in order. In today's lecture, we're going to explore something absolutely fundamental: linear algebra. Now, don't worry if that sounds intimidating. By the end of this episode, you'll see how linear algebra isn't just math on paper. It's the very foundation of artificial intelligence, machine learning, and even the apps you use every day. Here's a fun thought. Imagine trying to describe a picture, like a simple black and white drawing, using only numbers. Sounds impossible, right? But in reality, every single digital image is stored as a grid of numbers, rows and columns filled with values. That's a matrix. And the tools we use to manipulate those numbers, to sharpen an image, detect edges, or even recognize a face, all come from linear algebra. So in a way, linear algebra is the silent artist behind computer vision, deep learning, and so much more. Explaining core concepts simply. Let's break this down. Vectors. Think of a vector as an arrow. It has a direction and a length. In math, it's just a list of numbers. But in AI, vectors represent things like features of an image, or even the meaning of words in natural language processing. Matrices. These are grids of numbers like spreadsheets. They're used to transform vectors. Rotate an image, stretch it, compress data. That's a matrix in action. Eigenvalues and eigenvectors. These sound fancy, but they answer a simple question. If we apply a transformation to a vector, does it stay on the same line? Eigenvectors point in those special directions, and eigenvalues tell us how much they stretch or shrink. In practice, they're critical for understanding stability, data compression, and even recommendation systems. Singular Value Decomposition. Imagine you have a giant pile of messy data. SVD helps break it into simpler parts, kind of like reducing a song to its main beats and melodies. This is used in data compression, noise reduction, and most importantly, dimensionality reduction in machine learning. Real-world impact and AI connection. And here's the exciting part. Every time you train a neural network, linear algebra is working behind the scenes, multiplying huge matrices, adjusting vectors during optimization, calculating transformations. This is the language that deep learning speaks. Without linear algebra, there would be no ChatGPT, no self-driving cars, no recommendation algorithms on Netflix or YouTube. It is truly the backbone of modern AI. So, the next time you see a vector or a matrix in your textbook, remember, it's not just abstract math. It's the engine powering some of the smartest technologies in the world. In our next episode, we'll dive into another giant, calculus. We'll explore how derivatives and integrals aren't just classroom exercises, they're the key to optimization, gradient descent, and backpropagation in neural networks. So make sure to follow us by clicking the link below, and don't forget to check out the playlist in the description. Trust me, you don't want to miss what's coming next.